Good afternoon. Our next speaker is Katie McLaughlin. Sorry, just Katie is speaking now. On you go.
Oh, yay. Good afternoon, everyone. I will like to point out firstly that I am wearing a skirt that is covered in bees. Bees! And this talk is Snek in the browser. So, hi, I'm Katie. We are going to be diving into some fairly technical content today. It might be a bit daunting for some people who haven't heard of these concepts before, but we'll get there. And like any good talk, we should start with some definitions. So, the first and most important definition of all, what is Snek? According to the most reliable source of information on the internet, Tumblr, Snek is comprised of a danger noodle with a snoot for booping. Snek is very cute. Snek has a snoot for booping, hello friend, you smell funny, head boops, and is currently in the posture of a noodle ball and is very cute and adorable. And I like Snek. Snek is cute. However, this isn't about cute snakes. This is about the other snake that we may know of, Python. But more importantly, what is Python? This might be a little bit trickier to define. Python itself isn't a language. It's a language specification. When you type in Python into your terminal, what you're actually using is CPython. What is CPython? CPython is the most common implementation of the Python language specification. If I have in my terminal, I have a file called Snek, and all Snek does is print out, hey Snek, and a Snek, because emoji is fun. If I want to execute that file, I would write Python Snek, and it would print out Snek. But we have more than one way to execute this code file. What I could do is I could use the interactive Python interface. I load up Python, it's loading Python 351. I can import Snek, and it would print Snek. However, after I have imported Snek, I end up with a dunder PyCache folder. Within that is a whole bunch of gobbledygook. But there's a Snek in it. So what does this do? This is what the Python interpreter compiled and then runs as it does because it's a computer. And computers can read this code even though humans cannot, except there's a Snek in there. So if we want to, say, work out exactly what that gobbledygook meant, we can save a string as Snek, and we can use the dis module, and we can ask it to dis Snek, which is a tongue twister. But what we end up getting is this. This is disassembled raw CPython bytecode. Bytecode is an intermediate interpretation of the CPython implementation, which is then run against the Python virtual machine. Now, it looks a little bit like assembly code or BASIC, very similar. The Python virtual machine is a stacked-based language, so there are some similarities here. But using disassembler, the dis module, we can pretty much read what's going on here. So if we take a copy of what we had in our code and compare it to the bytecode, we have line 1, which is our print statement. We load a name, which is print. We load a constant, which is the string, hey Snek, and then we call the function using the first positional argument, which is the string, and no keyword arguments. And then we return a value. We can take this a little bit further. If we have a file that has two variables, not just one, we have S, which is Snek, and B, which is a B, and we want to print the concatenation of those two. If we import dis again, we open up the file and we ask it to read the disassembled code. We end up with something like this. We have the first line, which is one variable, the second line, which is another variable, and then we load print, we load Snek, we load B, and then we have a binary addition. We call a function, we get the result of the function, and then we load a constant return and we do interesting things. This is all CPython does under the hood. And all these functions are really easily described, and there's only about 100 or so of them. What we could do is we could write our own. in 500 lines or less, which is what Alison Kupta has done in 500 lines or less, a Python interpreter written in Python. There's only so many commands we need. CPython is just fancy syntactic sugar on top. So you could write it all in bytecode, but not a lot of people want to. Well, not a lot of people want to. Some people do like to. That is Snek. It's Python. You compile it down into basic commands, and then you run those commands. But who is browser? So you may recognize one of these browsers. There are many. They've come and gone over the years. But these applications allow you to interact and surf the information superhighway, also known as the internet. You may have heard of it. This is a window, a browser window. We have an address bar, which shows us where we are, and we have a window which shows us the content. This is all made using HTML, hypertext markup language, which gives the information superhighway its look and feel. We have a series of a combination of markup tags which we can use to define the structure of a page. We have HTML, within the HTML is a title, a body, within that body is a header 1, and a paragraph of content. We can also make the information superhighway look prettier with cascading style sheets, CSS. This can take our browser from its drab but functional state into something that looks a little bit more fancy. We can do this by importing a CSS style sheet in our head tag, in our HTML. And CSS looks something like this, where we say the body, we want it to have a different font, and we want our headers to have a different color and size. We can extend our HTML form and allow us to interact with the surfing of the internets. Well, not actually. What we're doing here is we are creating a form that enables us to send information to a server backend from our client frontend. This allows us to interact with the infotainment superhighway, which is the basis of how the internet works. This is a form. The form has a label, an input field, and a button. What we can do is we can put in data into the input field and then press the button and it sends it and returns it back. If we want to validate what we have in this form, we need to do things on our server side. Now, this is where Python comes in. Remember Python from earlier? We're going to use some Python. If we wanted to validate the username that we have in our form, we could declare a method called validateUsername. We take a copy of the username and we check whether the original username matches the old username. What we can then do is a whole bunch of changes to the original username to check whether it still matches. So for a valid username, we want to make sure it's all lowercase because we can't have two users that have upper and lowercase things with the same letters. We also want to make sure there are no white spaces because when you enter in your name on a mobile, there may be some spaces and that just confuses machines. And because we hate Unicode, we want to make sure that you can't use any emoji in your username. So this could be a business logic server-side validation for that form, which is great. This handles everything that we want from the server side. The problem, how would we use this exact same logic client-side? What we could do is we could re-implement it all in JavaScript. JavaScript is the native language of the browser. JavaScript won the great language war from many years ago, defeating such veritable foes as Flash, Visual Basic, JScript, and ActiveScript. Thank God. To ensure we have the same validation on both the server side and the client side, we need to recreate that exact validation function exactly. So we have a function called validateUsername. We copy the variable that we're taking in to another copy, except that's not proper JavaScript. What you're supposed to do is put a var in there, because that will make sure that it's a local variable and not a global. This is fine. What we want to make sure is that at the end, if the two variables don't match, that we return false. Except that's not valid JavaScript. What you have to do is you have to wrap your if condition all around with brackets. That's fine, except no, it's not, because true and false in JavaScript actually have lowercase letters to start their script. This is fun. We're just transcribing things directly. We have absolutely no chance of describing what we actually want the logic to be here, right? We haven't even done any of the changing yet. So what we want to do is we want to make sure that USR does not equal UN, except That is not valid because what you need to do is you need to use double equals. If you use single equals, if you have an integer and a string, they could be coerced to say that, oh yes, the string 1 matches the number 1. You need to put a double equals if you want it to actually validate. Triple equals if you're using equality, exclamation mark double equals if you want to check the exact inequality. So now we need to do the lowercase stuff, and that's fine. We can just look it up on the internet because we can see that instead of lower, we use 2 lowercase. That's fine. But the next thing we wanted to do was to strip the white spaces. There is no native strip function in JavaScript if you're using older browsers. There is now a trim though, but that only works in browsers newer than IE8. And then there was the removing of the Unicode characters. So what would we do there? Well, you could maybe iterate over all the integers, all the characters in the string, making sure that they have a code that's within the valid ASCII set, or you could use a regex, and then you'd have more problems. Or you could use encode URI component to convert any of the non-ASCII characters with percentage signs and then compare that to the original string. Or why can't we just use the code we had that we know that works in the browser? Well, you can. Introducing BeeWare, the Ides of Python. Remember our bytecode from earlier? Yes. Within the BeeWare suite, we have a wonderful little tool that allows us to take that exact bytecode and run it in the browser. So instead of having these 4 different languages that we have had to use so far, HTML, CSS, JavaScript, and Python, we can remove the JavaScript using a Batavia. Why is this particular object called Batavia? Well, this is the Batavia. No, that's not the Batavia. That's a model of the Batavia. This is the Batavia. The Batavia was a ship, a Dutch merchant ship that in the 1600s sort of crashed into the side of Australia. There's a little bit of a mutiny, it's fine. It crashed not far from Perth, which is where the creator of the BeeWare project, Dr. Russell Keith McGee, resides. Now, the Batavia, with its small mutiny problem, was supposed to be going to Indonesia, specifically Java. So the Batavia is the world's first Java ship. Now, Batavia the project is a Python virtual machine implementation in JavaScript. So the B in BeeWare is helping pull along our Snek into the browser. So here's our Python function from before. If we were to put that function into a file called validator.py, and then we open up our Python interpreter, we import py_compile, and then we ask it to compile validate.py and put the output of that into compiled.pyc. The pyc file then is gobbledygook, but we can see that the content still has our lower, our strip, our encode, valid username. Instead of using that gobbledygook because copy and paste an emoji in Unicode is terrible, what we can do is we can do the same function as before, import base64, and then encode our file in just base64. If we then print that out, it's something very easy to copy and paste. It may not be very human readable or at all unless you spend a lot of time staring at bytecode. Yeah, I know exactly what that's doing, blonde, brunette. It's a matrix reference. This is a very easy string to copy around. So what we can do is back in our HTML code, we can add our batavia.js, which is our JavaScript implementation of the Python virtual machine, and then we can add our bytecode, which means that in our form from earlier, we can invoke the validate username function. And what we can say is if we have a USR string that is using jQuery, because jQuery is wonderful, we ask it to get the value of the username field, and if it's not valid, pop up an alert. Our validation function in here is sourced from the Python. We're using a little bit of JavaScript here just for readability. But what we do is in our form, we add an onSubmit validate form, which means that in our form, if we try to put something in that's invalid, we get an error. And this is all using the Python function that we implemented earlier. But how? How did Batavia get this to all work? So Batavia is, as I said, the Python virtual machine implemented in JavaScript, which works not unlike how CPython does. So let's take a look inside Batavia. Let's see its framework. This is actually the framework of the Batavia. We're going to follow the code, which is a little bit stripped down because it's JavaScript and it's a little bit hard to understand. I've cut some of these next slides down for a bit of readability. So this is our marshalling code. In our marshalling code, we load PYC, which is our function where we're going to load our PYC file, and we ask it to read the object and convert it back out of base 64. In our marshalling code, we then take our code, we cut it out into code and types, and then all we're doing is, based on stripping out all the blocks of our code, is we just step through it one by one. Are we dealing with a null? No. Are we dealing with a none? No. Are we really dealing with a stop iterator? No. Are we dealing with ellipses? No. This is exactly how the CPython interpreter works with its bytecode. It just steps through and works out exactly what you want to do in the less than 150 different functions. This is literally a virtual machine passing machine code, basic assembly style language in a stack. So that is Snek in a browser. Python running normally where JavaScript lives. But doesn't this already exist? I've gone through an entire story about how awesome this is, but there are a bunch of other solutions that already exist in this ecosystem. Who here has heard of Python Sculpt or PyPy.js? Yes. So all these solutions, they are absolutely wonderful. They do things great. They don't do it the way that we want to do it, so we made our own. No. Python and Sculpt are full implementations of the Python compiler and interpreter, complete with interactive prompt. We don't need an interactive prompt. We have our code already. We don't want our users to be able to type in their own stuff. We already have our code. PyPy.js is similar to these, except it has used Inscripted to compile the PyPy source code into JavaScript. These implementations are big, like huge, like 5 megabytes. Which is a lot. It may not seem like a lot, but if you're talking about a web browser, it's a lot. It's noticeable. It's more noticeable if you're on mobile. It's even more noticeable if you live on a small island in the middle of the Pacific. Hi. It's even more noticeable if you live on a small island in the middle of the Pacific and are trying to do this over Wi-Fi at a conference in the middle of the Pacific. So, we don't need a compiler, we don't need an interpreter, we don't need a REPL. We just need the Python virtual machine. So the Batavia size is only a couple of 100K. It's not exactly compressed too far down yet, but it's nearly a fifth of the size of the big ones. And we could compress this down more, we could do a whole bunch of things, but a couple of 100 kilobytes, it's negligible even over Australian internet. But wait, there's more. This is only part of the BeeWare suite. Remember our markup form from earlier? This is still HTML. We still have 3 languages that we're using in our stack. We could get rid of the HTML and the CSS and just stick with Python. This is where Toga comes in. Toga is a Python native, operating system native, cross-platform graphical user interface toolkit. Why is it called Toga? Well, when in Rome. I didn't name these things. The person that named these things is in the second row right here. You can speak to him afterwards. This is our form from earlier. All we're doing is telling a machine where to put pixels and vectors on a screen. We're just drawing. This is a high-level abstraction of drawing, so we don't have to draw all the individual characters, all the individual lines. HTML and CSS is just one way of getting stuff on a screen. But we have other ways of getting stuff on a screen. This is a basic Toga application in Python. We import Toga at the top, and then we have a class, superhighway. Within that, we declare our validation functions, we declare a startup, and then in our main method, we tell it that we're going to return superhighway. Within the little insert user interface here line, we declare our interface. We have a label called username. We have a username input box, which is a text input. We have a button. We have a box. We put the label in the box. We put the username text object in a box. We put a button in a box. We set some styling. We use the CSS Flexbox model here because it's a really nice way of being able to declare where you want stuff on a page. So we set some widths, we set some padding, we set some flex direction, and then we return the box and tell it to show in the main window. And that plus the previous slide is all you need. Then in Python, you tell it to load the module highway, and then we get our program in native Mac. And then if you try to input the stuff and it's invalid, you get a nice little pop-up, just as we had before. But this runs on my machine. What if you want to run it on your machine? Well, this is where Briefcase comes in, because we need to put all the stuff in a briefcase and being able to take it away to places, because all the names of all the projects are fantastic and very literal. What we can do is, if you have Briefcase installed on your machine, you run python setup.py macos, and you end up with a .app. This will show up in your Finder, and you can double-click it, and you get the application as you had before. This can be copied around to different machines. But say you don't want to have it running on a Mac, or you don't have a Mac. Say you wanted to have it running in one of those newfangled web browser thingies. Well, python setup.py Django, and it'll run as a Django app. Say if you don't want it running as a web, you want it running on your iPhone. Well, python setup.py iOS, and it's an iPhone app. But say you're on Android, python setup.py Android, and it's an Android app. Or if you're on Windows, python setup.py Windows, and it's a Windows app. Or python setup.py.linux, and it's a Linux app. All the platforms. Yay! But wait, there's still more. Toga is a toolkit and a collection of cross-platform widgets, which means we can declare a whole bunch of widgets, which means, you remember that browser window from before? That's just a widget. We can recreate that in Toga. If we have our Toga thing from before, we import the CSS from Colosseum. Colosseum is part of the BeeWare suite, which is to do with CSS because it has C and S and S in the middle of the thing, and it happens to be something to do with Rome. Puns. If we create a class called Grays, and in that we have a main window, but then we create a web view, and that web view, we have it an initial URL of the PyBee website and CSS, we can have this running as a native browser, in our native application. This is the Mac version, which means that yes, if we were to python setup.py Django, we could get a browser in a browser. I don't want to break the AV. How much time do I have left, Mr. Person?
7 minutes.
Wonderful. Okay, so the entire BeeWare suite, everything I've spoken about today, is Python 3.4 and Python 3.5 compatible. Python 3.6 is fun. You remember how I was talking about bytecode earlier? It changed, which is absolutely fine, because even though it's all documented, the bytecode implementation in CPython is not formal, it's considered internal, and there is absolutely no guarantee of backwards compatibility. What we're doing is silly. The basis of the particular change that has tripped us up is to do with how the operation codes that we were looking at earlier, load name, load const, are defined in code. They're all 16-bit units now. This allows for some amazing optimizations, and if you're using Python like any sane person, it's fine, you won't notice. But we're doing silly things. So, if we run our Snek from earlier, and we compare the MD5 sum from an execution in Python 3.5.1 compared to 3.6.1, the MD5 hash is different because we got different output, which means that it won't work in the browser, sadly. But you can help. And here's the call to action. We want you to contribute to BeeWare. We have an open offer to mentor anyone who wants to work in any part of BeeWare. We want people to help with the Java stuff, the JavaScript stuff, the widget stuff. Linux, if you know Linux packaging, we would really like some help with this. We are here all through the sprints, so another week. Oh goodness, we're here for a while. But if you contribute to BeeWare, you get a shiny coin. Ooh. Plus, if you haven't been to our booth yet, we have a second coin. We have a coin if you help people get their coin, which instead of the yak shaver is the yak herder coin. Ooh. If you don't want to help with the project, but you still want to, if you don't want to help with code or implementations in the project, but you want to help with the project in general, you can also become a member. We have membership options for individuals starting from $10 a month and companies from $100. We would love to be able to work on this as a job. We would love to be able to hire interns to help us work on it as a job. But we need money. So, jingle, 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 jingle. We have a booth. If you come to the expo hall for the rest of today and tomorrow at booth 103, we have a competition running. Who here has one of the PyBee badges? Team Purple! God damn it. Who here knows Babylon 5? Yeah, it's the Drazi thing. If to win an iPhone, if you come along to our booth, you choose a team. It has absolutely nothing to do with anything. But if you choose a team and enter in our project, you can enter in our contest, you can win an Android phone from Kogan. Kogan is Australian website, get hardware place. We also have a whole bunch of sponsors that I want to thank. RevSys for our original coins, Sticker Mule for our stickers, GitHub for our shiny new coins, and Travis CI, because if anyone was here at Sprints last year and remember how we kind of broke Travis, they're giving us more concurrency this year, so we can have more builds and more people working on the project. Yay! We're here all through the sprints, all 4 days. You will see the big hive of bees. Come join along, earn a coin, earn a second coin, help someone else, and thank you so much for your time.
Okay, we have 3 minutes for questions as questions and not statements, correct?
I would like to take questions in the form of a question. Hello.
Hi, thanks for the talk. That's amazing. I'm interested in how the performance looks.
It runs.
Excellent.
Okay. More seriously, we're not trying to mine bitcoins here. We're not trying to crunch DNA molecules or whatever. One of the other endpoints we support is Apple Watches. If you were to try to, say, mine bitcoins on an Apple Watch, your watch would turn into a molten pile of slag while on your wrist. There is definitely optimizations that can occur. If you have any knowledge of how to do this, please come along to the sprints and earn yourself a shiny coin. Thank you very much. Hey.
I think I'm going to ask the same question in a different form. Like, have you compared the performance relative to, say, other virtual machines like PyPy? Like,
we have compared it, yes.
On like just some
How much of the browser DOM do you have access to if you're using?
All of it.
All of it? Cool.
It's API wrappers. If you want any widget and you can't call it natively, you just make a wrapper around it. If you want to, say, have a special function called color and call it Team Purple and have an API widget that just changes everything purple, you can go ahead and do that. But the entire DOM is accessible, as are all native system APIs. We're doing zipper format. It's great. Hi.
Okay, so my question is, have you looked at WebAssembly at all? Or is it
We have.
been, okay, that's, I'll look it up.
Is there any sort of, do you guys know how stable the CPython bytecode is liable to be going forward?
I would love to know how stable it is going forward. The thing with Python 3.6 only affects Batavia, because in every other way that we get Python on things, we do it in other ways. There is a talk by Dr. Keith McGee on how to write a transpiler tomorrow at some time. That is the how to write it for Java, which is a different way of doing things entirely. The way that we're doing it is bytecode to bytecode, bytecode. We don't know whether it'll be the same in 3.7, yada yada, but it's just a little bit of a change in the marshalling. So just because it doesn't work now doesn't mean that it can't work. But if you would like to help, we're here throughout the sprints. We will openly mentor you if you don't know how to do it already, and we can work this out, and we can get you a shiny coin for your help.
Thank you.
One last one. Uh-oh. Hi.
Hi. How much of the standard library is available? I know there are obvious sort of black spots in terms of what's covered and what's not.
How much is currently implemented? I defer to the good doctor. Bits? Not a whole lot. However, no, okay, so how much time do I have?
You're out.
Oh, come talk to me later. Some. Thank you so much.